My project for the Interactive Systems Workshop is based off of the concept of a tower defence game, where enemies can only be delayed, not killed or stopped. This core mechanic is what I've built all theming and gameplay aspects around to create a working prototype. Players control a farmer who has to defend their lettuce patch from swarms of oncoming tortoise, using a variety of moves which slow their approach. At the end of a round, if players make it until the timer hits 0, they can progress to the next level, getting feedback on how much of their lettuce survived so they can try again to try and get a better score. For the demo, I built 3 levels with actions to flip tortoise, shock them, and place decoy food to lure them away from your lettuce. My first sprint was focused on building the basic mechanic. I made simple tortoise with cubes, which moved slowly towards a given point using vector3.moveTowards. I used Unity's built-in animator substate machine, which allowed me to create different states for tortoise to transition between which influence their behaviour, as you can attach different scripts to different animator states. Tortoise transition from state to state based on tortoise state number, an integer value saved in the animator which can be accessed from all the scripts. The first step was to make it so I could click on the tortoise and it would change to a paused state. By giving the tortoise box gliders, I was able to use Unity's built-in on-mouse over function to register when the mouse was hovering over a tortoise. I could then check the input to see if a player was clicking, and when it was, I could influence the integer value in the animator, triggering a change in state. My next step was to add goal selection, so tortoise could walk to the nearest goal in the scene. I did this by building an array of all the objects in the scene with the goal tag, and then iterating through all of them to find the nearest one using vector3.distance. From there, I simply used vector3.moveTowards and the game object that was set as the goal, and tortoise would move slowly towards that object. By being able to select a different goal, tortoise could have the ability to flip one another back over. This is done based on if they collide with another object, and if that object is a tortoise which is in the pause state, then it automatically transitions back to walking. I also gave the lettuce in the middle a health system, so that while it was colliding with objects with the tortoise tag, it would take damage. To make sure this wasn't just happening constantly, I used a coroutine which I would invoke after a certain rest period. So every 3 seconds or so, it would take another hit of damage. When it hit 0, it was destroyed. I built all my functionality for the lettuce in the food class. This made it really easy for me to start my next step, which was dropping decoy food. I could simply create an instance of the food class, which wouldn't affect the scores, but would still take damage and behave in the same way, acting as a goal for tortoise to move towards. This means that players could easily drop something else that would distract the tortoise and lead them away from the lettuce. In initial stages, this worked by the player right-clicking on a spot on the screen, and then a decoy food would be spawned at that position in world space. However, as I later changed to a different camera view, this ended up being just spawned in at various points within range of the player. Following some user testing sessions, I changed my camera view to isometric to make the scene feel more immersive, while still being able to see everything clearly. I also gave the tortoise random speeds to make gameplay less predictable. This works basically in the tortoise script, where at the very start, speed is initialized using Unity's math.random to pick a random speed variable between 0.3 and 1.5. This adds some good variety to the tortoise and means you kind of have to balance up which tortoise to aim and focus on because they're a bigger threat. At this point, I didn't really have a way for the game to win. You just had to tough it out and wait for your lettuce to die. So the next step was for me to add a countdown timer. This would go down as time went on, and if it hit 0 and you were still alive, then you would pass the level. To make the win and lose screens more interesting, I thought it would be a nice idea to have some feedback on how players did in the level. To do this, I had to create a global object which could be accessed from all the different scenes. This uses a singleton pattern, where it basically creates itself, and if there is no instance of itself already in existence anywhere in the game, then it makes a new version. If not, then it deletes the other version. This means you don't end up with 5 copies of the same thing, all holding different values. As you go from one scene to another, the values are preserved. This meant I could save things like the percentage of health the lettuce were on when you won, or the time left when you died, and give players some good feedback on why they scored well or low and how they could do better next time. My next step was to create a spawner, which would bring in tortoise at various points around the perimeter so that players didn't just start knowing where tortoise were going to approach from. The simplest way I found to do this was to make a game object from which tortoise can be spawned, and then animate the game object to move a continuous loop around the edge of the map. This was really quick and easy to implement, and means that players don't know which direction tortoise are going to approach from. Another important aspect of my spawner is that it has an integer value called maximum tortoise. This basically looks for all the different tortoise in the scene and says it'll only spawn them if they're below a maximum number. This means that you can adjust the difficulty of levels, because you could say in earlier levels there'll be a maximum of 3 in the scene, but in harder levels there'll be up to 20, giving it a good way to adjust difficulty without changing too many other factors. To avoid players spamming the different actions, they each had a recharge time. This meant that once the action was triggered, players had to wait a certain time interval, such as 3 seconds, before they could do it again. An issue with this in testing was that there wasn't a clear visual way to see when you had recharged your move. To combat this, I started work with some displayed bars which showed when you could do the next move. For this, I created a custom recharge bars class, which has methods into which you can pass a percentage to update how much of the bar was filled. In the next week, I built my third player action. This enabled characters to yell, which would stun tortoise within range, who then retreat back into their shell for a given amount of time. A basic animation shows the range affected and makes the move feel impactful as it bursts out and sends tortoise around into their shell. In order to implement this, I had to first change my input system. Up until this point, I had just 2 actions that players could perform, so I just had them on left and right click. With a third one, I needed a way that I could switch between actions. This is done by setting the decoy food and the yelling at tortoise as secondary actions, which can be toggled between using the spacebar. Bools hold which action is currently selected for the secondary action, so when the player enters right click, the script sees which action is currently active and carries out that action. I also upped my UI a bit to make it clearer by adding bigger icons for all the different actions, including yell, and switch the bars to circles to make the whole game look softer and make it more instantly recognisable as a charge up rather than a health bar. With basic gameplay implemented, I started trying to make my gameplay more fun and juicy. A key way I did this was adding some particle effects to the lettuce so that when it took damage it shot off bits of lettuce so you could really see what was happening. I then adjusted my global object to contain an array of Boolean values. These all relate to a level in the game and basically means that you can change the value to true when it's unlocked to enable players to go through them. This adds a good sense of progression and enables players to learn the moves gently. In the first level you could only flip, and then once you've got the hang of that and have passed it, then you're introduced to other moves such as decoy food and yelling at tortoise. The last few weeks has been spent polishing my prototype to balance the difficulty of different levels. I'm really happy with how my demo has come along in the last few weeks. I think it really shows off my unique twist on the tower defence mechanic, and I think it's going to be really fun to continue working on in the future. Thanks for watching!